Perlin noise is a technique best known for generating landscapes and textures, but it's also a good way to add an organic feel to otherwise sterile geometric designs. Let me show you an example. I'll start by creating a matrix of random unit vectors using the random vector matrix method of penplots. Once I've generated this matrix, I can probe for the noise value at any point using the Perlin noise function. Every Cartesian point corresponds deterministically to a single scalar value for a particular value of noise. I'm using a helper function in penplots called point matrix to show you what the noise surface looks like. I generate a uniformly spaced grid of points and calculate the Perlin noise value at each one. I also mark the result as a grayscale value, which causes Julia to render it as an image. Notice that the texture repeats in both directions. The number of rows and columns of the vector matrix I generated determines the period of repetition along the x and y axes, respectively. Each time I run this cell, I get a different result, so I'll also create a random number generator with a fixed seed and pass it in. Let's use the noise to perturb a circle. I'll start with a regular circle, and then multiply the radius by our noise. I'm only using one dimension of the noise for now, by keeping the y value constant. See how the circle has a cusp? That's because my rotation does not line up with the period of the noise. When I multiply by 6, which is the period of the noise in the x direction, the cusp disappears. To make things more interesting, instead of just tracing the shape, let's use the points along it as a center for similar, smaller shapes. I'm still only using one dimension of the noise texture, so let me fix that. Within each of the smaller shapes, instead of using a y value of 0, I'll use I, which represents how far we are along the outer shape. As before, I want to line up the period so that it repeats after one revolution. To see why, let me zoom in on the first and last couple of shapes. Right now, the first two shapes look very different from the last two. To fix this, I'll multiply I by 8, our period in the y direction. Look at the similarity between the multipliers we use here and the parameters I used to create the noise matrix. A common technique is to layer multiple frequencies of Perlin noise by adding them together. But even with one frequency, we have a huge parameter space to explore. I'm going to keep playing with these parameters until I find something to plot.